Hello everyone. Now I'm going to conclude my walkthrough of the four big tools of system dynamics with the saving interest model. And just to remind you, causal loop diagrams, more savings you have generates more interest adds to savings, and this is a virtuous reinforcing cycle. Behavior over time graphs, so you can see key variables. I've only graphed savings over time and what their shape looks like, so you can see a virtuous cycle. Reinforcing positive loop looks like this. The stock and flow diagram, okay, so savings is actually a stock, so it accumulates up. Interest flows into the stock, that's its only inflow. So in this model we're not taking any money out of savings. And then savings generates, savings times the interest rate really generates the interest. So this is the reinforcing loop in the stock and flow picture. And then lastly, we're going to deep dive into the Excel model and how to turn this model into an Excel spreadsheet. Now, I'm sure all of you can do this in this particular case. But the idea here was to just take a simple case of savings and interest that you would know intuitively so we can focus on the tools, not on the model itself. So there's a certain way to model it in Excel that makes things easier, and you can do this with hundreds of variables. So I build very sophisticated models using this particular approach. So I'm going to dive into the computer now and show you how to model stock and flow diagrams into Excel. All right.
Okay, now we're going to build this model in Excel, and what I did just to remind me of the variables is I drew it in PowerPoint and just embedded my slide in here so I can remember we have three variables: interest rate, interest, and savings balance that we need to calculate. So the way I build these things is I put the constants on top. A constant would be something that has nothing, no arrows into it. It's just a simple flat constant number, and we have one of these, interest rate. So I'm going to do 12% per year, and one of the things you'll discover later is it's best to name your constants. So you can go up to this name box and type in interest int rate or whatever, and that will it'll help you in a second. Okay, and then the main part of the model is really these variables over time. So let's do time in months for this model. Now you could do this, per day, per week, month, quarter, year, what have you, and it would calculate different numbers because if you compound interest daily, it's different than compounding every month, let's say. So you need to decide kind of the accuracy that you need. But for this, I'm just going to do months. I think that will be good enough. I start with time 0, which I'll explain in a second. But all the other months are basically the cell to the left plus 1. So let me just do a page full of those to make sure everything is calculating okay. So that looks good. Now for any stocks, let's take a look at our variable. Savings balance is a stock. So I do beginning savings balance, and then I do an ending savings balance, and leave space for the inflows and outflows in between, is the way I usually do it. This just makes things a little bit easier. What I mean by beginning and ending is in month 2, let's say, the beginning balance of month 2 is the same as the ending balance of the month before. And then the ending balance of month 2 is really the savings plus any inflows minus any outflows gives you the ending balance. So in our case, the savings plus the beginning balance plus the interest for that month is the ending balance. Okay? So, and then we'll put in interest. Okay, so actually we just have the one inflow. So any stock needs a beginning value. So let's say you had $100 in your account when this model began. And that's the only variables you need to fill in this time 0 is just any stock values, their ending balance. Okay, so now let's build the model. So basically the beginning balance of month 1, or any month, is the same as the ending balance the month before. The interest is calculated as the balance, the beginning balance, times the interest rate, and we're doing this per month, so I'm going to divide by 12. And then the ending balance is really the savings in the beginning plus the new interest, and that's your ending balance. Okay, so that's essentially building the model. So what I'm going to do is I'm going to copy this out to here, make sure it looks okay. And it does look okay. So you can see the interest gets bigger every month. The savings is getting bigger by a larger amount every month. So that looks like it worked. The reason you name a constant, if you can see in the cell, when you move things over, it's going to try and attach it to the interest rate over here in these cells. But if you name a cell, it knows to keep going back to that cell. So that's a little trick that I learned. So name any of your constants and your formulas are going to work out just fine. Now what I'm going to do is I'm going to just generate this out for like 100 months, let's say. So I've got 4 rows. 100 is around the end of the C's, as I've discovered. So I'll just paste that. Let's see. Okay, there, 102. Okay, so we got 102 months. And that's essentially the model. So now that it's in Excel, you can do normal things you can do in Excel. For instance, if you wanted to graph the savings, just click on row 7. Hit that graph chart wizard, pick a line graph, and then hit finish. And there you go. So there's a graph of the savings balance. It has that kind of exponential growth. It's not too pronounced with this y-axis, but that's the exponential growth. If you need to graph 2 variables, I'll just show you how to do that. You do interest and savings, let's say. So you select both rows. Click that, click line, hit finish. Now what you're going to find when you graph 2 variables is some have very different dimensions. So the savings is goes from 100 to 300, and the interest basically goes from $1 to I would guess $3 or so. So one of the things you often do in system dynamics is you have these mixed variables. So you if you select the line, I'm going to give it another y-axis, basically. So you select the line with a left mouse click. You hit right mouse click. You do Format Data Series. In the Axis tab, you say Secondary Axis. And then you hit OK. And then the interest is basically projecting on this axis and the savings on that axis. And you can change this axis if you want. In this case, the lines are kind of on top of each other. So you can say, oh, let's go up to 5 so you can see that a little bit better. And so you can see here's the savings on that axis, here's the interest on that axis, savings on the axis on the left. And you can name these things, you can name time down here, you can give it a title, you can do all the things that Excel brings to the table. So again, simple model, but if you do it in this particular form, you can do very complicated models and not have to worry about how exactly to model it. This way of putting constants on top, putting time here, doing a time 0, doing stocks as beginning and ending, doing a time 0 where you put in the initial amount and then just pasting everything forward works out just fine.
So now basically I've taught you the 4 basic tools of system dynamics. As I said, causal loop diagrams is probably the one of the more interesting parts, and then modeling this stuff in Excel so you can calculate kind of different flavors. So in our case, what if the interest rate was different? What if the savings amount, initial savings amount was different? What if I deducted $100 a month as an outflow? What if I deducted 5% a month as an outflow? You could try out different scenarios as you know in Excel and figure out what performs the best. So now the door is open for us to build much more interesting and sophisticated models in future videos, which will teach us a lot about how system dynamics really works in the real world. So with that, I'll close, and I'll talk to you next time.